So welcome everyone to another exercise on system Verilog constraint. And in this particular example, we have to write a constraint uh, to set to get unique values for for an array, and that too without using unique keyword. So let us begin. So let's say that we will be using this for a dynamic array, and let us assume and let us write a constraint which will declare that this dynamic array has 10 elements. So to do that, I need to use the size method and 10, and just to get a valid range, a readable range, so we will write another constraint which will iterate through each element of A, and it will write that AI, which means each element should be inside any range from 0 to 100. And now the main portion. So usually if you want to have every element to be unique, you would just write a simple constraint. You would just write the unique keyword, and using the parenthesis inside the unique keyword, you will just write the random variable for which you want the values to be unique. So usually you will do this way, but what if we want to do that without using the unique keyword? We could do that. So let's begin. So just to do that, you have to iterate through uh, every possible values and in two dimensions. So not in two dimensions, I mean for with two different separate iteration variables. So it's a single dimensional dynamic array, of course, and it will have 10 elements as mentioned in this particular constraint. So what I will do, I will iterate through the through every elements, and for first time I will use a different iteration variable. Let's say I'm using I. Then inside it, we will iterate through it again, but this time we will use another iteration variable. So it will create a matrix, a two-dimensional matrix of the same dynamic array in two times, in which it will work as a row or column and etc. So in this particular matrix, what I will do, inside this, I will write if the iteration variables are same, if iteration variables are not same, then that particular element should not be same. So it's a very smart approach, and it's a very common algorithm approach also. So here, what will happen? Uh, it will just create two separate metrics of the same dynamic array, and let's say it will have its own values like 1, 2, 3, 4, etc. And the iteration will start something like this. First when the I is 1, let's say this is I. So first the I is 1, then j will be 1, 2, 3, 4, and etc. So it will iterate like this in every occurrences of I, and same goes here. 1, 2, 3, 4, etc. And same goes for the other columns. So it will create a sort of matrix. So this particular if condition is very important for this constraint to work properly, and it is because it does not make any sense that if we, let's say if we remove this, then this constraint will fail, and it is because it does not make any sense that uh, each of the uh, each of the elements of ai with iteration variable I and a with iteration variable j are not equal, because it does not make any sense. After all, we are iterating through the same dynamic array, but with different uh, different index. So if we remove this, and if we come somewhere here in which uh, ai equals to 2 and aj equals to 2, and both of them are not equal, so it will not make any sense. So it will only compare other elements which are not equal. So that's why this particular condition is really important, because without it, the constraint will fail. And uh, uh, we are just iterating through the very same dynamic array, and of course, so let's say if we are here, the value of I is second. So if the second element here is 2, so of course the second element here also, if let's say j equals to 2, so which means a2, the second element here also will be 2. So for that reason, it avoids the condition of the constraint for the cases in which the value of I equals to j, because they will be same anyways. But if j equals to 3, if it's 3, then it should not be 2. It should be something else. It should be 3, 5, or anything from 0 to 100 as mentioned right here. So it should be unique. So that's how the comparison works. It avoids the comparison when we are referring to the same index and I is equals to j. Other than that, the value of I should differentiate to that of value of j. So this is very important in making the entire element as unique. So let's see whether this work or not. So first I will use the unique constraint. The name of the class is const1 and we will declare a handle. Let's assign an object to the handle. And let's randomize this. I will use the immediate assertion. So let's compile the code and check whether I have made any typos. Okay, it is fine. So let's start the simulation. Oh yeah, I forgot to write something that will display the value. So I will just write post randomize function. And here I will use simple %p just to display the values of this dynamic array. So as you can clearly see that right now, since we are using the unique keyword, it is obvious that each of the elements will be unique and will not be equal to each other, and they are ranging from 0 to 100 as we have discussed right here. So if I will not use this, so we could get some crazy values that we can imagine in int. So every value is unique, and yeah, so now we will just comment this one out and we will see that whether our particular algorithm is working on or not. So here I will repeat this again. We are iterating through the same dynamic array, which is a single, which is of a single dimension, and we are iterating through it again with another index variable, which is creating a kind of uh, two-dimensional image of the same unique array. And what will happen? We are writing a condition that if both I and j equals to 1, which means that let's say if ai equals to 2 and uh, here aj equals to, I mean the j equals to 2. So if the elements are same, therefore this condition cannot be implied and the constraint will fail, because after all we are iterating through the very same dynamic array. So we are writing this particular condition to exclude those cases in which I is equals to j, and then we are writing this particular condition which will maintain the uniqueness of each elements with respect to each other. So let's see whether this work as per our intention or not. So everything is same. I've just commented this constraint. Let's run the simulation and let's check each of the elements. So you could clearly see that each of the elements are unique to each other. So therefore, our particular algorithm of iterating multiple times through a single dynamic array passes. And you could see that the first element 86, then 76, 41, 74, 91, 8, 97, 43, 16. So hence we have no repetitions and every element is unique to each other. So that's all about this video. I hope you find this lecture useful and thank you so much and stay tuned for more. Thank you.